I didn't know yesterday that I make a talk here. But don't mind, this is my talk. I started since 1990 with amateur spectroscopy, and there was a large break, but now the children have flown away. I'm retired, and I restarted this in 2017 and focus on a single star. This is Alpha Camelopardalis, Alpha Cam, an O star, a hot star, O9.5, supergiant, with a strong wind. Now, this is a drawing of the star. The black spot in the middle is the star itself, the photosphere. The strong wind goes out from the star in every direction. It's always accelerating. It's not like a football. Comes not back. It's accelerating to a final speed of 1,500, 1,600 kilometers per second. The star has a diameter of 25 solar radii. And temperature is about 30,000 Kelvin. Okay, what does the observer see? Observer is located here, looks upwards, but 3,000 light years away. The expanding atmosphere, the wind causes a Doppler shift. In this half of the wind we see the lines are blue shifted. In the other half they are red shifted. Here slowly red shifted, large red shift. We see this component of the velocity and this, all only in the direction of our viewing. So we have the continuum of the star. Besides is something added. The hot star brings the wind to emission. This emission adds to the continuum. And now we see redshift continuum and blue shift continuum with some additions. The upper gray field behind the star we cannot see. This is missing in our view. So the red shifted region is a little bit lower. But the blue shifted is also lower because the wind in front of the star causes absorption lines and not emission lines. The emission is overwhelmed of the very light. What is hell?
Bright.
Lightful.
Bright.
Bright. Danke, thank you. The very bright continuum. So we have the red shifted part, the blue, but there's absorption, below to various speeds. Here the speeds are slow and the maximum speeds are measured with UV lines. I cannot show this. Okay. Keep this in mind when I show you the spectra. You may add some fountains spitting hydrogen if necessary. You may take a vacuum cleaner to move it away. You may add a companion. And this star is a very rapid runaway star, so we may have collisions with the interstellar medium. Okay. Now try this to interpret the following spectra. These are 20 spectra gained in March 22 from me and my friend Berthold. And the spectra are all H-alpha spectra. They origin from a near region of the star where the right temperature and density is. Additional, the hot star does, of course, make ionization, and we have lots of free electrons. These free electrons scatter the light, especially the strong H-alpha light, H-alpha light, and the scatter makes Doppler shifting. We have a broad pedestal, broad socket. Oh, you find this everywhere.
Wings. Broad wings. Yeah.
Broad wings of electron scattering, also known as Thomson scattering. Okay, I show you the spectra and will not talk very much about, yes, you let work your imagination how this, what you will see, can happen, where this comes from. The first spectrum is alpha line, of course, not by zero. The zero is stellar surface. And here you see a helium and also helium line, and the electron scatter is here and here. Okay, and the date. 20 spectra. The day after.
The day after?
Yeah, the day after.
Oh, yeah.
Yeah, hey. 20 solar radii. Huh? The day after. Two days later. Can you imagine something that can eat up the absorption? Oh, it will vanish totally. Next day.
The absorption we have to understand like the physical profile.
Yeah. Yeah.
Yeah.
Yeah.
It means that the wind component in the observer's line of sight, this
Yeah.
physical
Yeah.
component
Yeah.
in
Yeah.
the
Yeah.
observer's line of
This
sight
is
is different.
free of my.
Yeah? Ah, yeah.
2 days later.
Mhm.
Now let your fountains bite enough hydrogen. Or soak it away. Don't know. These lines do not vary.
Can I,
One
can I
day
say
later.
something?
Yeah.
I just checked, but the lines you have, the absorption lines you have on the right, it's a dip. It's a interstellar line.
No.
It is.
Helium.
No.
Helium 1 from the star.
No, it's
No,
a dip.
6614. It's
Yeah.
It is a helium line.
It's not helium one. It's not helium one.
yeah.
No.
You just
No.
put it in the.
It's
valence
not
space.
interstellar. No.
It is.
No.
Yeah.
Let's use the Doppler formula and convert
That's what I
the
did.
velocity into valence. The valence of this line is supposed to be 6614,
Yeah.
Yeah.
not 6678, which is the helium line.
No.
So this is
This is a bit-
interstellar, but not that one.
No,
Not
the
that-
other one is helium too. I think no.
It's iron,
Yeah.
probably
Oh,
6515
yeah.
something.
Yeah.
Iron.
I'm
No.
not sure.
No.
9.1?
No.
Yeah.
You are wrong.
I would.
That is something easily to be checked.
I have multiplication.
Yeah.
But what is also too narrow? Yeah, no, it's a dip.
Oh,
I use it all the time to check the velocity.
Okay.
Please leave these lines alone and explain
Yeah.
explain the H Alba mountains. Two days later.
Günter,
Yeah.
I think something is happening in the outer atmosphere of this star.
Yeah. Yeah.
And even if the helium 6678 absorption is more or less constant
Yeah.
during your time
Yeah.
schedule,
Yeah.
means there happened something exactly, but only the outer atmosphere, not within
No,
the deeper
no,
area.
no, no,
No?
no, 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 no.
No?
The helium 1?
66?
6678.
The helium 1 line is not in the same place as the alpha line.
Yes,
Yeah,
of course. Yes,
okay,
yes,
yeah.
yes.
But,
It comes from the photosphere of the star.
well,
But not only, it can pass in emission quite quickly.
Sorry?
6678 can pass in absorption, in emission quite quickly.
Yes, yes,
So you
yes.
need to check. You need to check 6678 and 5876
Yeah,
because those two are the first helium one that pass in emission.
yeah, yeah.
But the one at near H alpha before the one in.
oh,
in
stop,
the-
stop. This is my stuff. We will look up what helium line this is. I don't know. I play around. It's an improvisation. Huh? Not a prepared talk.
Okay. Okay.
Same day, 3 hours later.
What's the visual brightness of the star?
4.3.
4.3.
One day later. Huh? Oh, here. Schon beeindruckend, ne?
It is.
It is impressive.
It's very impressive. Yes, absolutely.
Yeah.
4 days later, we have clouds. Sorry.
With what?
Clouds, Wolken,
Clouds.
clouds, yeah,
Clouds.
clouds.
Interstellar.
Yeah.
Terrestrial.
Yes.
One day. Huh? Yeah. One day. No absorption.
Well,
And
unique
shifting
one,
in
no?
wavelength, obviously.
Yeah, depends on
The
what.
shifting in wavelength.
Yeah,
obviously.
yeah. How can you fill up this absorption line?
Well, the face value explanation would be you have a strong change in the mass loss rate.
Yes.
Yeah. That is one. I think what is more worrying is that the wind velocity is also changing
Yeah.
from some of the spectrum to another, and then stays again
Yes.
stable.
That is
It's
visible.
actually quite low.
Well, that is the effect of H alpha. So
Yeah.
That's obviously seen in the wavelength shifting. No?
This is the kind of thing I've already seen in colliding wind binaries.
Mhm.
Again.
I've seen this kind of change in colliding wind binaries.
Okay,
Yeah.
But I don't know if that one is a binary.
not listed as one.
Isn't it supposed to be a binary?
Oh, star.
I don't know. Yeah, yeah, of course. Yeah, I know.
This is usual known as a
But I mean
binary
the
system.
approved one.
For some years they say it's binary,
Uh-huh.
and other years it's alone.
Uh-huh.
Long eclipse.
It's a lot.
Long eclipse. Just like in movie CGI.
Yeah, yeah. When the binary is in the upper strong.
One day later, the absorption comes back.
Oh,
Boom. No, no.
Well, the absorption is still there.
Yeah.
You have what you would see this little dip, and you have just a broader emission which just fills it up.
It's only on the left side.
Yeah.
So it's,
Well,
velocity is negative.
yeah.
That's okay.
3 hours. 3 hours difference.
Günter,
Yeah.
was this profile changing in different areas of the profile? Was it totally unknown before you investigated?
No, 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 no.
It was known?
It is known.
Ah, it is known.
It is known, and it's not very. It is not regular.
And what tells you in the literature about this phenomenon?
That was my.
Different.
Yeah.
They don't know.
They don't know.
Then it would be very fine scales.
Yes, yes.
Clapping. Wind clapping.
Some of the features,
Or
yes.
porosity.
Here you can compare
If a stand doesn't go to that extreme.
my spectrum in red, and 6 minutes later the spectrum from Berthold, made by Berthold, to see any differences. There are differences, of course. It is not easy to normalize this spectrum.
Yes.
You can't see really the continuum. Huh? No, we don't like. So we are nearly at the end.
Nice piece
This is fine.
Yeah, this one is
Fine, it's simply with electron scatter.
Yeah.
This is my observatory.
This
Yeah.
green beads.
Yeah, C11 and
They're rotating.
the rope. Yeah. And a little stift Lyris.
When the wavelength of different lines are shifting, you are able to move your...
Yes, that's right. That's right. So, that's the end.
Yeah, great, great.
Thank you.
Yeah.
So I'm expecting answers from you. If you have answers to me, you can get now.
Do you have to set that up every time you want to observe?
Yeah.
Yeah?
Yeah. Yeah. The telescope is in the house.
You don't have an observatory.
My garden is my observatory. I love my garden. I want no observatory fixed in the garden. Yeah.
So just a comment. I mean, I do this stuff as well, and I love seeing your slides. And irrespective of the astrophysics, it just makes the point for me that, or that I make to people, that I find it absolutely incredible that I can see stellar dynamics from my backyard. I just find that it blows me away every time I get some spectra like this with that sort of variability. From my backyard, I can see stuff that was only just detectable 60 years ago or something. I mean, I don't know. You tell me. But that just it's awesome. That's all I'd like to say.
The professionals started in the 80s. Ibitz is the first.
Yeah.
1982.
Leads me to the question, what does it mean, the professionals in brackets?
Not in brackets.
No, what does it mean?
The professional is one that gets paid for the work, and we do it for them. Okay, good. Thank you. No answer.